I wasn't sure if my column was going to be tall enough. I'm now pretty sure it will be. I have to make a clamp to fit on the force gauge. I'm still in the thinking stage for that one. But it shouldn't take up much in the way of height. I'm going to mark on the base where the center of the force gauge's threaded shaft is. I want to try and keep the wire as straight up and down as possible. I think that will be important in getting a good reading for the pull-out force of a crimp terminal. For now, I'm going to try this vise for the base. It should clamp on the end of a terminal quite well. For that matter, it will probably clamp on a wire quite well too. Only I need something much lighter in weight to screw onto the force gauge. I'm going to line up the fixed jaw to the center spot I marked on the base. That was the entire point of marking the center position of the force gauge. I'm going to use a couple of clamps to hold the vise to the base. I think 2 will hold it just fine. If this vise works okay, I think I will order myself a smaller version of this one. First thing I want to do is see if I can apply 50 pounds of force with the knob I have on the carriage. This is the hook attachment that came with the force gauge. It doesn't look like much, but it should be at least rated for 65 pounds. I've got a 16 gauge wire here, so that should easily handle 50 pounds. I'll set the gauge to pounds and set it to peak reading. Okay, that wasn't thought out at all. I'll twist the lead ends together and then clamp it in the vise. That should hold. A little over 40 pounds is very easy to obtain. To get over 50 pounds, I'm having to work a bit. I would say I can get to 48 pounds with no stress on my hand. 55 pounds is a little hard. The maximum for this gauge is 65 pounds, so I want it to be hard to get to 65 pounds. I think this is good. I would really have to apply extra torque to the knob to go up over the maximum force of the gauge. And if I need 50 or 55 pounds, I'll get a little exercise. The last piece I need is a clamp for the force gauge to hold a loose wire end. I want it to be kind of lightweight, and the clamping faces need to be flat. I believe any ridges or sharp edges will just cut into the wire. I have a 1.65 inch long, 5/8 inch in diameter piece of 6061 aluminum bar here, and I'm going to try and make a clamp out of it. First thing I'm going to do is make the 6mm by 1 female thread that will mate with the force gauge. I'll start with a center drill. The 5mm drill bit is a bit flexible, so this will make sure the drill bit stays on center. I'm drilling a 5mm hole a little over 0.6 inches deep. I don't have a 6mm bottoming tap, so I'm drilling a little deeper than the 0.4 inches of thread I want. I'll chamfer the edge of the hole. It makes a much better looking thread. I'll use the lathe to hand tap a 6mm by 1 thread. This setup does make sure I get the tap nice and straight. I have the drive gear disengaged for the chuck, so it turns very easy. That way I can feel how much torque I'm putting on the tap. Mainly I want to feel when the tap gets to the end of the hole. Torque will go up fast and I want to stop there. No breaking any taps today. I'll clean all the chips out of the threaded hole and that part of the process is done. I need to drill 3 holes straight through the center of the round bar. I'm using a 5/16 inch lathe tool blank as a spacer to lift up the square. That way I can clamp the aluminum bar up where I can see it and see my marks. I want to position it so I'm in the center. It's not the most critical thing, so I'm just doing it by eye. And I'll start the first hole with a centering drill. The tiny drill bits I'm going to be using for 2 of the holes would walk all over this rounded surface. I've got a number 53 drill bit here, and this is going to take a bit of time. I'm going to go very slow with this drill bit. I only have this one, so I can't break it. Really, I should have the drill speed higher, but I've only got the 2 holes to do. About 3.5 minutes to drill the hole. I expect the second one will take about the same. Again, I started it with a center drill, and I'll do this one the same way. Very little pressure on the drill bit for a bit, then lift to clear the chips. Every few plunges, clean the bit off and apply a bit of cutting oil. I have a 4.2mm drill bit for the third hole, and I also started this one with the center drill. Hard to get any regular drill bit not to walk around on the rounded surface. This hole won't take near as long. I still don't want to apply an excessive amount of force. I don't want the aluminum piece to move in the vise. I've got to cut a slot in the end of the aluminum bar, the end with the 3 holes. So I've got it held in a V-block mounted in the vise with about 1 inch of the aluminum protruding from the vise. And I need the holes to be straight up and down, so I'm using the drill bit as an alignment rod to assist me in that quest. If I have everything set right, the cut should be in the center of the aluminum bar, perpendicular to the 3 holes. This is a slow process as well. The drill press isn't that rigid, so I have to go very slow. I'll keep plenty of cutting oil on it. The depth of cut for this slitting saw is only about 7/8 of an inch, but I will get the cut as deep as I possibly can. The blade does do a nice job of cutting and leaving a pretty smooth finish. Okay, that looks good. Much straighter than I could have cut on the bandsaw, and a lot smoother too. But there is one more cut, and that one I will have to do on the bandsaw. I'm going to cut at an angle to the slot I cut with the slitting saw. Again, I'm using the drill bit to align the piece. It will be a rough cut, but this surface will not be used for clamping, so it won't matter. There we go. This has been a good old bandsaw from Harbor Freight. But any little catch on the blade will kick it off the drive wheel. And really, in this case, that's a good thing. I have my 2 pieces, the starting of a clamp. I'm going to file all the sharp edges down. Can see how smooth the cut is from the slitting saw. I think that will make a good clamp surface. I might be better off with some ridges in it, but I'm not sure how I could make some non-sharp ridges in the aluminum. I'm going to try it flat and see how it does. The larger piece will have the 4.2mm hole tapped for a 5mm by 0.8 thread. I just did this by hand. It's not that critical, and I had a taper tap to do it with. I've got to enlarge the 3 holes on the small piece. Again, I'll use some spacers to position it where I want it in the vise. The 2 small holes are going to be enlarged with a number 52 drill bit, so I'm increasing the hole size by about 0.4 of an inch. Might have to go a bit bigger, but I'm going to try this first. It needs to slide on this spring steel pretty easily. And it seems to. Now the 4.2mm hole will get enlarged with a number 5 drill bit, a close fit for a 5mm bolt. Now the piece gets turned over, and from the flat side I'm drilling a 1/4 inch hole about halfway through. I probably should go a bit deeper. The more spring that will fit, the better. But again, I'll try it like this. I'm going to clean all the oil off the pieces I cut. I've cut the spring into 2 short pieces, kind of making me a couple of spring dowel pins, a bit tiny ones. I have a 5mm by 0.8 bolt, a knob to fit the bolt, the spring which I will have to cut, and a washer. That should be everything I need to make the clamp. I'm going to use a bit of 320 grit sandpaper to knock the edges off of the spring pins. I think I'll have to do something more drastic for the ends that go into the movable jaw. I'm driving the pins into the fixed side. They're snug, but not as tight as I would like. The movable jaw fits, but it's too tight. I need to round off the edges of the pins. I'm going to use the Dremel with a fine stone on it to smooth off the ends of the pins. I may have to enlarge the holes 1 more drill bit size. That's not bad. The ends of the pins are still a little tight. I'll grind them down a little more. I think that's a good fit. Maybe a bit tight, but it will probably loosen a bit over time. I'm going to put a tiny bit of CA glue on the pins. I want them to stay put on the fixed jaw side. Hopefully this glue will give them a bit of extra holding power. I'm going to drive the pins down until they are flush with the movable jaw side. Whatever extra is sticking out the fixed jaw side, I will just cut off. I think I can get half this spring into the jaw. I threaded the fixed jaw for the 5mm bolt. I plan on gluing it in place so it won't turn. I don't see why that won't work. I'll bend the cut end of the spring down, fit it into the recess of the movable jaw, and then put it together. Tighter than I would like going together. I will probably have to increase the pin clearance holes a bit. Nope, can't quite get half the spring into it. I should have gone just a bit deeper with the recess. I'll take a couple of turns off the spring and it should fit then. Okay, that got it. Jaws are touching now. Put my washer and knob on. And that looks like it's going to work. At least the jaws are fitting together quite well. I'm going to use some of the CA glue on the bolt. I was planning on using some epoxy, but I think this will have plenty of holding strength. Not only is the silicone mat heat resistant, I found CA glue doesn't seem to stick to it either. Makes for easy cleanup. I'll wipe it off, don't want to get my fingers glued to it. And I'll just snug it down. There's not a lot of threads in the aluminum. I just want the bolt to stay put when I'm turning the knob. And I will cut off those spring pins at some point down the road. It screws right on the force gauge, so that's good. That's all the pieces in place, so let me see if I can pull on some wires. This is a 20 gauge wire. I think I'm going to want to make the wire strip length the same as the jaw length. That way there won't be any angle to the jaws. I'll position the head assembly where I want it, and then clamp the wire into the vise. The vise on the base is where I plan on clamping the crimp terminals. Oops, I'll put it on pounds and 0 it. It's either stretching or slipping at a little over 20 pounds. Didn't break or cut any strands, so that's good. I'll put it back in and try again. Yes, started to slip at a little over 25 pounds. I may need to make myself a larger clamp knob. I'm going to really crank down on the clamp knob to see if a larger knob would help. Okay, that broke the wire. Looked like around 27 pounds, and most of the strands broke at the same location, probably the strongest pinch point in the jaws, so I don't really think a larger clamp knob is going to get me much. Once I start smashing the wires, I've gone too far. This is going to be the big problem with this clamp on very small gauge wires. Now to try with some 16 gauge wire. This may only be 4 gauge sizes larger, but there is a huge difference in the amount of copper between the two. Started slipping around 45 pounds, but slipped from the big vise. Didn't expect that. That really makes me feel good about my little clamp. Let me really torque it down in the big vise and then give it another try. Whoa, looks like it hit 57 pounds before slipping. I'll consider that an overload condition. Didn't break the wire, so that is very good. I do think this is going to work well for the larger wire gauges. I think we'll use it like it is for a while. If the jaw is still too tight, then I will enlarge the holes for the spring pins, but I would expect it to loosen up a bit with use. This is a 26 gauge wire. I think I'm going to have trouble with wires around this gauge. Around 4 pounds, it's pulling the wire apart. The strands are just so small. I think the tiny ridges on the jaws are cutting into them. But one of the strands did break from the very smooth jaws of the large vise, so maybe the clamp pressure is deforming the strands enough to weaken them. It may be I have to come up with a completely different scheme to clamp the very small gauge wires. But I do believe this clamp will get me started. It will probably work okay to maybe 22 gauge. Below that size, I doubt this clamp is going to work. I didn't crimp any of these terminals. They're from a PC power supply. The wires are 18 gauge, probably very cheap wire, but the crimps look very nice. This is a PCIe power pin terminal. It has a quite short wire crimp area. Don't believe I even hit 25 pounds. Now some of that could be the PVC jacket, but I think that is kind of good for such a short crimp area. And my clamp worked quite well for that. Let me try with the same type of terminal but with the peak hold function turned on. 27.1 pounds. I think some of that is the PVC jacket, but it couldn't be more than a pound or two, if that much. So very good crimps on these terminals, at least I think so. Here is a terminal for the PC 4-pin Molex power plug. Its wire crimp length is probably twice the PCIe power terminal, so I expect a lot more pull is going to be needed. 42 pounds before the wire slipped in my clamp. That is really more than I would expect it to hold on the PVC insulation. I'm going to try and loop the wire around the bolt, see if that will give me more slip resistance. It could also just break at the bend where the wire is on the thread of the bolt. Okay, 50-50 shot of that working. Probably if the bolt was smooth where the wire wraps around, it would help. It cut the wire right at the bolt, so I'm sure one of the threads just sliced through it. Let me try with the insulation on the wire. Same Molex PC power terminal. Even the contact ends of these are thicker than the PCIe pins. Takes a lot of force to mash the contact end flat. I'll loop the wire around the bolt and would hope the PVC would keep the copper wires off of the threads. Feels like it's slipping, but I think the wire is just moving tight around the bolt. There it goes, a little over 49 pounds. That is more than I would expect from this terminal. Again, the PVC insulation is crimped into the terminal, and the ones I will do will not have the insulation crimped. I want the wire pull-out force, and only the wire. But this is going to work quite nicely. Haven't even started testing, and I've already learned something. All these years of pulling on the PC Molex power connector shell, and not the wires. Turns out that was a waste of time. I could have just grabbed the wires and pulled it apart. Thank you for watching.